Okay guys, so welcome back to my YouTube channel. So for the second part of the video today, we'll be focusing on Newton-Raphson Method. Okay, so before we focus on PSPM based question, let's see how the Newton-Raphson equation is derived. Okay, so for this, we'll first imagine that there's a graph, okay, and the one that I've done in black color, which is the main curve, okay. This is our main function, and x naught over here, if you notice, I've highlighted in blue, is our root. But the problem is that we don't know what is the value of x naught. So that's our job. We have to find the value of x naught. Okay, so how we do that is that we find first an approximation. Okay, so let's just say we approximate somewhat over here x3. Okay, so once we've got to here, we just interpolate it. Okay, so I've actually interpolated it. Okay, so and then we draw a point here. Okay, so x3 intercepts the curve at here. Okay, so the next thing we do, we find a tangent to this point, and I've drawn here. If you can see the one in yellow, I've drawn the tangent. Okay, and we find the x-intercept as well. Okay, so this is how we have to set our mind really. So this is how we have to conceptualize in our mind, is that now we have two graphs. One is our main graph and another one is this. So this is a whole different graph of its own. That's how we have to conceptualize our mind. Okay, so once we have done that, we find the equation of the tangent, in which x3 over here, we treat it as 0 as the starting point of the graph. Okay, and we have our own y-axis here, our own x-axis, and our own x values, and this side will be our x-intercept. Okay, so we find the tangent for the main curve. Okay, so as we know, the tangent is definitely a linear equation, so we use y equals to mx plus c, and we just substitute in the information. Okay, so for this is m is definitely the gradient, so the gradient of the tangent is also equals to the gradient of the curve at point x3, since x3 is our first approximation and that's our tangent. Okay, so I've written it like this, and then next is our x values. Okay, since this is a whole new graph, so we have our own x values, in which the x values need to minus off with x3, so that because x3 is the starting point, so we just minus it off with x3, and then plus with c is our y-intercept. So according to this new graph, the smaller one which I've circled, this part over here is our y-intercept. So it's at where the point x3 is located at. So f of x3 is our y-intercept, and the next thing we do is just substitute our x-intercept over here. So this is our x-intercept, we just substitute in, and we just rearrange in this form. Okay, so and then if you look closely, alright, x2 over here, x2 is a better approximation compared to x3 for the root of the equation. Why? Because x2 is located closer to the root of the equation. So we do the same thing as what we did with x3. We find the tangent, make our own graph. So the graph is located here. Okay, this is another subgraph. So we definitely again have to make the equation of a tangent with our own x values, and x-intercept, y-intercept, and we just do basically the same thing as what we did for x3. Okay, so we find the gradient, x values, y-intercept, and so on, and we just rearrange in this form. Okay, okay, so now as we can see, between both of these equations that we have made earlier, it shows somewhat of similar functions. So there's a similarity over here. So once we've got to this point, we just make our general equation. So our general equation is equals to x n plus 1 equals to xn minus f of xn over the derivation of it. Okay, so in other words, this is our general formula. Okay, so I hope you understand how we derive it. Next, let's look at a PSPM based exercise on how we can counterattack or how we can solve questions using Newton-Raphson method. Okay guys, so for this we have exercise 1 over here. Now let's first read the question. So by using Newton-Raphson method, find the root of equation for x squared e power of x equals 7. Correct the 4 significant figures by making x naught equals to 1.5 as our first approximation. So once we've done this, okay, we just push or we bring 7 to the other side, in which we equate it equal to 0. We equate it to 0 and we equate it then to fx, so it's like another function. So this is same as this, as what I've done over here. Okay, so once we've done this, we find the derivation of it. Okay, the next step is to find the derivation of this function. Okay, so by using product rule, we will get somewhat this as our derivation. We use product rule, we simplify it, and I just factored it and I get this. Okay, and then we just rearrange all of it in our general equation form. In this form, we rearrange it. So this is our fx, and then this is the derivation. We just bring it into this part. Okay, so then without further ado, we just substitute our first approximation value, 1.5. So we will get it is equals to 1.3689. Okay, and then next what we do is that we make that as another approximation as x2, because it will be a better approximation compared to x1, and then we substitute in the value into the same equation, and we will get x2 equals to 1.3489. So our aim is that we need to substitute in until we get two same x values. Okay, and for PSPM, so the marking system is that for the first approximation and second approximation, you need to show your substitution, meaning you need to write it like how I've written it here. For the third approximation, you can just write it like this and then just substitute it using your calculator and then just write the substitution value. So we've got x3 equals to 1.3489, and it's not the same. And then we substitute it again and we get x4. So x4 is equals to this x3. So once we get two x values that's same, that is our stopping criteria. In other words is that is our root of our equation. So once we've got this, we just make the conclusion, which is the root of the equation for x power of 2 and e power of x equals 7 is 1.3483. And as we know, they have asked in 4 significant figures, we just give our answer in 4 significant figures like this. So guys, I hope you understand how we get this. So that's how we are supposed to solve questions based on Newton-Raphson method. And if you don't understand anything, just leave your comment on the comment box below, and I'll come and see how I can help you guys. So that's it from me. Thank you very much.